So today we'll cover langchain RAG part 1. Basically, RAG enables us to prepare a chart, intelligent chart application, and it has like few sections. We'll just see it here. As part of it, what we will do is we will load a content, a document, and for our example here it will be a web page. We will scrap the text from the web page. It's a blog, and then we'll split the text, and we'll embed it and store it in a vector store. After that we will retrieve and generate. So retrieve will have both the question as well as the question embeds as well as the vector stored embeds. It returns the retrievables, and then it gives to a chart model. The chart model makes it to a proper text format and returns it, right? So yeah, this is what, so I've implemented it here. We have installed all the required packages: langsmith, anthropic keys, langchain anthropic, langchain openai. Now yeah, this is one important thing to remember is openai is the embedding model. Anthropic, the sonnet 3 is the chat model. Sonnet Anthropic doesn't provide embedding model, so we are using the, if you see here, this is a pretty standard model, text embedding 3 large, and this is our vector in memory vector store embedding. Here we are scrapping the data from the web page and we are loading it, and this is total characters, 43,000 characters. This is the step where we are splitting the text. So we are using a recursive text splitter to splitting it. Chunk size is 1000, 200 is the like a chunk overlap. Basically, we don't want to lose the context of the text. So let's say some page, while at the end of 1000 text there is some related topic, right, which is they're saying, and the next chunk size it won't have. So we are keeping the chunk overlap in order to not lose some of the important context that's around this thousands text. And yeah, we're splitting it here, and then we are adding those documents to the vector store. We are storing the embedding here. The vector store has like a OpenAI model here, so it's already coming from here, embeddings, vector store, and embedding is the OpenAI embedding of text embedding 3 large. So yes, and yeah, we have come here. We're just seeing the question context. We're giving a prompt format from this page. You can customize the prompt format as well. Here is the important part. Here we are coming to langgraph now. We are setting a graph which has few nodes. Now we have a node start, basically. So langgraph has three things, right? It has application state, it has the nodes, and the flow of the nodes, right? So we have first retrieve, which we are defining here. Retrieve gets from the vector store, does a similarity search of the question, and retrieves the documents and give it to generate. Generate does like uses the chart LLM to get the message and make it to a proper text response, right? This is the whole step: start, retrieve, generate. Now the next, now here is an example. The question is, what is the task decomposition? and it fetches this answer. Task to process is a method of breaking down complex tasks into smaller, more manageable steps. It's getting from the vector store. Okay, doing this similarity search. All right, now we are here. Um, yeah, then the next, now we are adding some metadata here. Whichever is on the first third, we are giving middle, beginning, middle, end. Basically, the next part is to implement a query analysis. So I'll just show the graph here. We are adding an analyze query before retrieve. What it does is users gives all kind of commands and queries, right? The analyze query basically feeds it to a LLM and makes it a better query for the LLM to retrieve and generate. That's all it does. And that's what we have. This now, this is another implementation where I have this analyze query node, and this is the search. So this is forcing the LLM to a structured output, and then invokes. So this takes the question, invokes the question, and makes it a proper query format, and that query format goes to retrieve for better retrieval and generate. Right, that's all we are adding here. It's another step here. You can see the Mohammed graph here, Mohammed diagram of the graph. So analyze, query, retrieve, generate. So if I've printed, so we can see the response. So this is the query. Task decomposition, it adds this metadata, this data to it, like it's a proper format. Task decomposition section towards the end, and if you see, it ends that and returns the answer with it. So that's all. We have implemented this one drag first till the end here, and the next tutorial will start for the part 2, where we'll do like lot of to and fourth conversation through a chain conversation. So all right, thank you.